Hello and welcome to my video on factoring. And in today's video, I'm going to be talking about the greatest common factor. So this is something that we use whenever we're trying to factor an expression. So we're going to talk about what it means to be a factor and what it means to be the greatest common factor, and also when we factor out a greatest common factor, what it is that we're actually doing. So there's a lot to talk about here. This is just going to be a quick little overview. If you'd like a more detailed explanation about anything that I'm covering in this video, please let me know in the comments. So without further ado, let's go ahead and jump right into it. So the first thing that we need to start is, what is a factor? So let's take a look at two numbers. Now, the reason why we're looking at two numbers is because whenever you're factoring, you're going to be given an expression that has multiple terms. We'll talk about what terms are when I write an expression, and you're going to be looking at multiple terms and trying to identify factors that they have in common. Well, what are factors? So let's take a look at 12. Factors are a pair of numbers that multiply to a desired number. So let's say 1 times 12. We know that's a pair of numbers that's going to multiply to 12. So those are factors of 12. We also have 2 times 6. And then we also have 3 times 4. And then if you moved on, you say 4 times 3. Well, that's just a repeat of the one I wrote before. So I actually don't need that one. So I have 6 factors of 12. It's going to be, now if you want to, actually, I'll just leave it like this in this format. So we've got 6 factors of 12, 1, 2, 3, 4, 6, and 12. We also want to do the same thing with the 18. Well, I know 1 times 18 is going to give me 18. I know 2 times 9 will do the same thing. I know 3 times 6 is going to give me 18. Then 4 does not work. 4 times, there's no integer, well, we'll say natural number, which is just your counting number. So there's no positive number that's like a counting number greater than 1 that I can multiply with 4 to give me 18. 5's not going to work. And then 6, well, if I got to 6, that would just be multiplied with 3, which is just a repeat of what I had before. So I know I can stop here. I've got 6 factors of 18. Now, the next step is to compare the factors. So comparing the factors, I see that I have a 1 and a 1 in common. I have a 2 and a 2, I've got a 3 and a 3, and then I have 6 and 6. So those are the factors that I have in common. Now, what it means to be a greatest common factor is just what is the largest number in that group? Well, 1, 2, 3, and 6, I know 6 is the largest number. Now, we can also extend this idea to variables. So let's take a look at something like x to the 4th and maybe x to the 5th power. Now, just a reminder, x to the 4th, that's just 4 multiplications of x. X to the 5th, that's 5 multiplications of x. So factors of x to the 4th, so I need a pair of quantities that would multiply by x to the 4th. Now, I really want to use integer exponents, or well, natural number exponents. So kind of like before, when we had the 1 times the 12, I know 1 times x to the 4th. Well, this 1 is really like x to the 0. So instead of writing x to the 0, you're just going to write a 1. Now, I know if I did an x to the 1st power, I'd have to multiply with an x cubed to get an x to the 4th, because that's how properties of exponents work. If you have two things that have the same base, the base being here the x, and you're multiplying them, you would just simply add those exponents. So then I'll have x squared times x squared is another pairing, and then I would go to x cubed and x to the 1st, but that's just a repeat of what I had before, so I would stop there. Now, same thing with x to the 5th. You would have x to the 0 and x to the 5th, but we don't write x to the 0, we would just write 1. Now, you would have x to the 1st power times x to the 4th power, and then you would have x to the 2nd power times x to the 3rd power. And if you moved on to the x to the 3rd power, you'd have to multiply by x squared, but that's a repeat, so we don't want that one. So let's take a look and identify the common factors that we have. Well, don't worry about the 1, because we usually never factor out a 1. That doesn't change anything, so you can ignore that one. But I can see that they have an x to the first power in common, an x to the second power in common. We also have an x cubed, and we also have an x to the fourth. So what is the largest thing they have in common? Well, that's going to be the largest power of x that we see. That's going to be x to the fourth. So that's going to be my GCF. Now, we're going to tie these two ideas together with some examples that we'll work through. So the first example, we'll start simple. Let's just say we have 6x plus 12. Well, now we have to identify how many terms we have. Well, terms are separated by addition, subtraction, equals, inequality symbols. Now, with factoring, you're not going to have the equals. You're not going to have the inequality symbols. You're just going to be having terms that are separated by addition and subtraction. So I see that I've got one addition symbol here, and there's two things that are separated by it, which means I have two terms. Now, whenever I'm factoring out a greatest common factor and I have numbers and variables, I look at them separately. I'll look at the numbers with the two terms, and then I'll look at the variables. So the first thing I'm going to look at is the numbers. Well, my first term here is a 6. I've got 1 and 6 are factors of 6. 2 and 3, and that's going to be it. Because if I did 3 and 2, that would just be a repeat of the first one. So we would stop there. Now, I'm going to look at 12 and say, well, we already did factors of 12. That was 1 and 12, 2 and 6, 3 and 4. So of those, what is the largest factor they have in common? Well, that's going to be the 6. So I know that I'm going to factor out a 6 from both of these terms. Now, what do I mean by factor out a 6? Well, all that means is just using the distributive property. So the distributive property states if we have a number, now I'm just going to use two terms here. We'll say b plus c. This is equivalent to a times b plus a times c. So you took this a and you distribute it. You use multiplication with both of the terms, and this is an equivalent expression. So let me move this down a little bit. Now, going from left to right, we multiplied. Now, what if I'm starting with the right-hand side and I want to go back to what I have on the left-hand side? Well, I can use the inverse operation by dividing. So once we identify that greatest common factor, you're just going to divide both terms by that GCF. So now, going back to number 1, or this example 1 here, they're both divisible by a 6. Now, I'm going to factor out a 6. So that's the first thing that's going to come out. And then you want to look at the variables. Well, there's only one term that has a variable, so they don't share that factor in common. So there's no variables that we're going to factor out here. So the scratch work is, all we're going to do is we are going to, let me use a different color. We're going to divide both things by 6. Well, 6 divided by 6 is going to be a 2. 12 divided by, sorry, oops, I said that backwards. 6 divided by 6 is 1, and then 12 divided by 6 is 2. So all that's left over is a 1 times x, so we're just going to write the x. And then we have the 2, and remember, we factored out a 6. So you can always check your work by starting with what you have and then using multiplication, using that distributive property, going from with both of the terms that you have inside that parentheses. So let's take a look at an example like 15, we'll say y cubed plus 25y squared. Now with something like this, I see that both of those numbers, the 15 and 25, I've got two terms here, they end in a 5, and my divisibility rules tell me that because I end in a 5, both of those numbers are divisible by 5. Now, if you wanted to write out your factors of 15 and 25, you can certainly do that. So you would have 1 and 15, and then you would have 3 and 5, and that's going to be it here. And then 25 is just 5 and 5. Well, they have one factor of 5 in common, so that's what I'm going to pull out of my expression. So to make this simple, all you need to do is just ask yourself, what is the largest number that both the 15 and 25 can be divided by evenly? So I want to factor out a 5. Now, I want to look at the variables now. I see I've got 3 factors of y here and 2 factors of y here. So because that second term only has 2 factors of y, that's the most I can factor out. So I'm going to factor out a y squared. So now I'm going to divide both of my terms by the GCF. That GCF is that 5y squared. Now I'm going to use a different color because I don't feel like that blue that I used was that teal, turquoise kind of color was the best color. So we're going to divide both things by 5y squared. So 15 divided by 5, that's going to give me a 3. And then 3 factors of y divided by 2 factors of y is going to give you a y. Plus, and then 25 divided by 5, well, that's just going to be 5. And then 2 factors of y divided by 2 factors of y is just going to be a 1. All right, so now let's put everything we've talked about into practice with a larger example. So let's say we have 18 a to the second power times b to the third power. I'm going to have to slide this down to make some room. Then we have plus 27 a to the third power, b to the second power, minus 9a to the fourth times b. Now, instead of writing out all those factors, I'm going to try to be smart about this and just remind myself that I'm going to look at the numbers separately and each of the variables a and b separately. So with the numbers 18, 27, and 9, what is the largest number that all 3 of those numbers can be divided by evenly? Well, I know that 18 is divisible by 9, 27 is divisible by 9, and 9 is also divisible by 9. You can look up some divisibility rules, but I just kind of refer to my multiplication tables. So what numbers multiply to 18, 27, and 9? And I just kind of go from there, just kind of reverse engineer my divisibility, knowing my times tables. So 18 divided by 9, that's going to, actually, we need to factor out a 9. Oops. And then let's look at the a. So we have 2 factors of a here, we have 3 factors of a here, and 4 factors of a here. So the most I can take out is 2 of them. Now, for my b's, I've got 3 factors here, 2 factors here, and 1 factor here. So I'll write that exponent there. So the most I can take out is just 1 power of b. Again, my scratch work is just going to be dividing each of these by that GCF. So looking at the first term, I have 18 divided by 9. That's going to leave me with a 2. And then 2 factors of a divided by 2 factors of a. That just becomes a 1. We don't write that 1. 3 factors of b divided by 1 factor of b is going to be a b squared. Now 27 divided by 9. Now there's a positive there in front of that. So positive 27 divided by 9. Well, that's going to be a positive 3. 3 factors of a divided by 2 factors of a just leaves 1 left over in the numerator. 2 factors of b in the numerator divided by 1 factor of b in the denominator is just going to be 1 factor of b left over. And then here I've got a negative 9 divided by a negative 9. Well, it's really a negative 1, so I'm just going to write a minus. We don't really write that 1. And then we have 4 factors of a divided by 2 of them, which leaves a squared. And then 1 factor of b divided by itself is just going to be 1. So here is my factored expression. I had 3 terms here because there was an addition and subtraction. So there are 3 things that are separated by those symbols. Now, hopefully you learned a lot in this video. Actually, I've got a problem that I'd like you to try. All right, so here is your homework or your practice, however you want to think about it. So we have 35 r to the 6th power times s to the 4th power minus 42 r to the 4th power times s to the 3rd power plus 49 r to the 3rd power times s to the 2nd power. So take a stab at this one. We'll have a video with the solution for this problem. So hopefully you'll get it correct, and keep an eye out for that video. If there's anything you'd like me to elaborate on, please mention that in the comments, and I'll see you in the next video.